everyone. Welcome to the next talk this afternoon for this room. Today we've got Brendan Higgins, and Brendan's quite happy to take questions from you while he's talking. If you want to ask him a question, could you raise your hand and I'll bring you this microphone, talk into your mic, and he'll answer. Okay, so Brendan, take it away.
Thank you. Yeah, like you said, I kind of view this as, I kind of want this to be a discussion. This talk is for people in the kernel community. This isn't for me. Like, I don't care. Like, I don't want to just get up and talk for the sake of talking. I don't really like slideshows, so my slideshow is probably not going to be very good. So we can make it more interesting if we talk about whatever you guys want to talk about. So I'm totally fine if we get completely derailed. I think that would be great. So yeah, so I'm going to be talking about KUnit, unit testing for the Linux kernel. It's something I've been working on for, depending on how you count, somewhere between 2 years and 18 months. Yeah, so I guess first thing, my name is Brendan. I see a lot of people here who I've not met. I see a lot of people who I have, but for those of you who don't know, I work at Google. You can see that by my Google email address. And I spend pretty much all of my time right now working on KUnit, or at least all of the time that I'm paid to work on things. And previous things that I worked on are server bring up, and I've also worked on OpenBMC. I see some OpenBMC hackers in here, so yeah, cool, represent. Also a very cool project. Yeah, so why are we talking about this? Why unit testing? Why KUnit? I think the best way to convince people is just to let it speak for itself. So I gave a demo at Plumbers, and I realized while I was doing a demo that doing demos on stage is hard, even for something that's very simple. So I just decided a recording would be better. Okay, so here I ran all the tests, and there's this failure here. So it shows you where in the file the failure occurred. And now I'm opening it up in Vim to inspect the error. Super exciting. So it prints out the line number in the file where the expectation failed. And I'll talk a little bit about expectations later, but actually, just to get a sense of the audience, maybe I should pause this. Whoops. Okay, that. How many people here are familiar with things like JUnit or Google Test or the Python unit testing module? Okay, that's about half the room, I would say, maybe a little bit more than half. So let's see if I can fast forward this. Yeah. Okay, yeah. So, sorry. I shouldn't have paused that. I should just let it go. Sorry. Anyway, so for people who aren't familiar, this is in the way. This is what I get for trying to go off the cuff. Okay, good. It's running. Yeah. So here I'm just looking up the value. I compared two values that didn't match. And I know it's an error no, so I should have just used the command line tool, but I don't know, for some reason I just looked it up. But anyway, so there was an expectation that failed. An expectation, you probably are already familiar with the idea if you've used one of the things I've mentioned. If you're not, a unit test case is basically made up of a set of expectations or assertions where you're making statements about the state of the system. And it's very simple. You're just calling functions, and then you're checking that the function returned the thing that you expect it to, or you get a data structure that was modified by a function, and you're just asserting that the right thing happened. So this will probably be a little bit clearer when I actually go into an example test case. But anyway, I think one of the things you can see is that it's really fast. And one of the things that's also really nice about unit tests is the language that you're testing in and the way that you interface with the code that's under test is the same. It's the same thing. you just call the code that you want to test directly. So you don't have to have some sort of test harness, or you don't have to have a script that you're running in userspace. Any symbol that's exposed in the kernel, you can call through the unit test. So the difference here between KUnit and other types of testing is basically that KUnit is unit testing. So I know for at least half the audience, this is going to be probably a little bit boring while I explain what unit testing is. If you've used any of those testing frameworks, you already know. But for the benefit of anyone who hasn't heard, unit testing is not the same thing as testing. I know that for some people, this may be a surprise, and for some people, this is not new. But there are people who I've talked to who don't know the difference between unit testing and testing. They think that they're synonymous, so they're not. There are a lot of different ways to categorize testing, but the way I like to categorize it is there's unit testing, integration testing, and end-to-end or system testing. I think probably everyone here, presumably everyone here works on the kernel, at least in some respect. Can you raise your hand if you don't work on the kernel in any way? Okay, so there's actually a good number of people here. That surprises me. So, okay. So anyway, for the people who do work on the kernel, you're almost definitely familiar with end-to-end tests. End-to-end tests are where you would install the kernel somewhere, and then you have a test that you run from userspace or something like that. Another way you might imagine this is if you have like a web server or something, you actually start the web server in a non-production environment, and you have maybe something like Selenium that attempts to visit the web server and make sure that the web page looks good. That would be an end-to-end test. A unit test tries to test a single piece of code in isolation. That doesn't mean like that function or file that you're testing can't call out to other files or resources, but the point is you are actually testing the unit, and in the case of C++ or Java, this might be like a class. For C, it's probably a little harder to define exactly what a unit is, but you're testing a single logical thing without anything in between you and what you're trying to test. These tests should not be dependent on hardware. They shouldn't be dependent on really anything that's non-deterministic. There's some exceptions because some things are difficult to remove the non-determinism from, but anyway. And consequently, because of these features, they should be very, very fast. Like an entire suite of unit tests should run in under 100 milliseconds. Like when I said the 100 milliseconds, I don't just mean a single test case. I mean like you should have a suite of unit tests that runs in under 100 milliseconds. So I think that's probably a lot faster than most of the kinds of testing that currently exist for the kernel. There's some exceptions, but anyway. And integration testing is like the in-between case, where it's kind of hard to come up with an example with the Linux kernel because I've seen things that I'd probably categorize as integration tests, but like an integration test would probably be something like you have your entire like server binary, but you don't actually deploy it in like your web server environment. You are testing just that binary by itself or something like that, or really it's just something that's in between an end-to-end test and a unit test. So just summarize, unit tests, the scope is very small. Because the scope is so small, it's very easy to achieve coverage, and so if you have a lot of unit tests, your coverage over the course of a unit test suite should be very high. The speed should be fast. Your confidence in the parts that you're testing is very high because you have very high coverage, but your confidence in the entire system is low because you're not testing the entire system. And end-to-end tests are the opposite. The scope is massive, it's the entire system in some cases. The coverage is consequently small because combinatorial complexity of all the different ways, the states that your entire program can be in, it's just usually not feasible to achieve very high coverage using only end-to-end tests. But the trade-off is that you're actually running the system in a production-like way. And so the things that you test, you're very confident that those parts of the entire system work. Yeah, so obviously I'm spouting off a bunch of things that I didn't invent all of these ideas. None of this is really original. KUnit is an XUnit style unit testing framework or unit testing library. That's why I said, like, if you're familiar with JUnit or the Python unit test module or Google Test, you're pretty much already familiar with this. It's a very straightforward implementation of an XUnit testing style. So I said what a unit test is, but what XUnit is typically you're going to have a bunch of test cases. Like a test suite is broken up into test cases. Each test case tests a single aspect of functionality. So for example, for like a list interface, which we're going to look at, you might have a test for every method that you have on your list interface. Together, the test suite tests the logical unit, and I already explained what a unit was. And one of the other things that's just kind of commonly done is because all the test units are testing related functionality, there's usually a test fixture that's shared that basically allows you to instantiate all the stuff that you're trying to test. And so there will be the setup, tear down, and then the context, the test fixture is passed around. So an example of one of these test cases we can look at is here. So here we have a test which tests the linked list data structure in the Linux kernel, and it's testing the delete init method. And so the first part of the test, we set up a list that has two elements. So there's the list, and it has elements A and B in it. Then we've already tested that add works in a different method. I just thought this one's more interesting. So we've already tested that those things work, so we're confident that that works. And then we call delete on it. So now we verify at the bottom that the state that the nodes and the list are left in is what we expect it to be. Does that make sense? Does anyone have any questions about this example, or is it straightforward? Is it clear? Yes, you have a question.
So can I put KUnit expect foo into the implementation of listdel init and have that compiled out when I'm being compiled into the kernel, and this is just being run in user space?
So are you asking for basically, could you do an inline assertion that gets compiled away? No, we don't do that. The model I've gone with is that tests are separate from code. That's actually kind of something, we've run into some interesting cases with that. And I don't know, that's maybe a direction we could take the discussion portion of this talk. I'm curious to see what people think in that regard. If there is a school of thought that believes that unit tests should be in line with the code that they test. I personally like to keep them separate because I think that seeing the test mixed in with the code makes it harder to read the code and harder to read the test, but that's just my bias, that's what I think, and there's a lot of people who think the other way, so, if that's what everyone else thinks, I don't really care. So if you want more information on XUnit, I don't want to spend the entire time talking about XUnit and stuff. I think it's a very dry topic. Some people have written some really great descriptions on it. Martin Fowler is probably one of the best examples. Also, I talk about KUnit and all the different concepts that make up KUnit in the documentation. So, next portion, where are we going with KUnit? The current state of KUnit, it's been accepted upstream. It's going to be in 5.5. It's already been merged. Currently upstream we have about 7 test suites. I say about 7 because I know that there's a current, like one that somebody's currently working on, so it'll probably be 8 in a couple of weeks, but, or, well, it might not get merged this cycle. But anyway, across those 7 suites, there's around 100 test cases. We've found several bugs. And the features that I talked about in terms of defining test cases with test fixtures and stuff, we support that. The test run on any architecture, I put a little asterisk there because we have a script that you saw me run in the example, which builds and runs all your tests for you. Currently, that only works with UML, but you can just manually scrape the kernel logs for the test results, and that works on any architecture, at least all the ones that we've tried so far. So, and we also have this resource management API, which the idea behind that is there's a bunch of resources that you want to instantiate as part of the test fixture, the code that you're going to test on, or code that is a dependency for the code that you want to test on. And hypothetically for because each test case should be hermetic, you want to recreate that that infrastructure after every test case. So we have some infrastructure to help you. When you create that, it'll automatically get destroyed after every test case, and then it recreates it at the beginning of every test case. So is there any questions so far? Is there anything that anyone would like to talk about? Yes.
I start at the back.
Thanks.
I've got a couple of other questions. Maybe you'll answer
Yeah.
this later. Maybe I'm jumping the gun. How does it actually execute? Are we insmounting a kernel module to execute these tests, or what is the running mechanism? That's one question.
Yeah.
And then the other question is how do you handle the fact that you might panic the kernel?
Right. So, so the first thing, the first part of the question is, yeah, KUnit just runs as part of the kernel. And the preferred method for running your tests, the thing that the script does, is it builds a UML kernel, which the kernel as a user space application. And so basically, it's fine if the kernel crashes or whatever, and it's really easy to scrape the results out of. If for some reason you need to test architecture-dependent code, the recommended way of doing that would be to run it inside of a VM like QEMU or something like that. Does that answer both of your questions?
Yes.
Cool. Thanks. And I saw a couple other hands.
Yeah.
Yeah.
Just wondering, going back to that sort of example test case, I noticed that your test, So I noticed you're using a sort of context structure for each test case.
Yeah.
Can you describe briefly like what that contains? Like what sort of stuff you can do with it?
Yeah, so the one thing that, I would say the only thing that a normal user should have to care about is there's actually this magic context pointer, which is basically where you're supposed to build up that test fixture that I mentioned. I could probably, it might be a good idea if I just pulled up a example of a test case that does that. But anyway, all it is, it's just a pointer, and I think it's called like CTX or something, and you just put whatever you want in it. Okay. The other fields in KUnit are all internal, and you're not supposed to care about them, but they contain the appropriate things to make things like KUnit expect and things to work. So for the most part, it's just a totally opaque object that you're not supposed to care about. If people want to go over the design of KUnit, I can do that, but I don't think it's going to be super interesting. So do people want to look at like a more complete example, or is that a good explanation? Okay, I didn't hear anyone say, sorry? Okay, cool, yeah.
So I have another question. So are the tests limited to only exported symbols or any function of the kernel?
Yeah, so this actually kind of gets into the point that Matthew brought up earlier about tests being in line with code. So we actually ran into this instance with, one of the tests we added recently is for AppArmor, some of the infrastructure for parsing the policy files, the policy unpack code, if anyone's familiar with that. Anyway, are people vaguely familiar with like AppArmor policies? Yeah, okay, so, anyway, it's a bunch of parsing code that parses some like files from userspace. And the parser was entirely contained within one file, and so almost none of it was exported. And so to make the testing easier, the decision that we came down to was just put the tests in the file, so they had access to all the static functions in the file. There were a number of people on that thread who seemed totally okay with that, so that's a way to do that, but there are other ways that we thought of. So I don't know. Do we want to talk more about that?
Well, follow-up question to that is, so you mentioned at the beginning that the test case should not rely on any hardware, specific hardware.
Yeah. Yep.
And I guess that comes from the fact that you're running that as a user mode Linux.
Right.
So what about running KUnit as a kernel module, and you run the test in module init? Because
yes.
then you could test functions, export symbol, of course, in that case only.
Yeah.
But those functions say anything that has to do with the block layer, where you have to look at the state of a device.
Yep.
That would still work.
Yeah. So actually, that is something. That's one of my next slides I was going to go to. I think it might actually be the very next slide. Or wait, no, I don't know. It's one of these slides. But I talked about what we're currently working on. And someone actually recently sent, we recently merged patches from somebody, Alan McGuire. He pretty much did. I don't think he's here. I've not run into him, and I think he would have said hi. But anyway, still, if he ever watches this video, thank you, Alan, for working on that. He added module support for KUnit, so you can do that now. It's not going to be in 5.5. It'll probably be in 5.6. So, yep. Yeah, so challenges working on KUnit. I think probably the most obvious one, which is sort of where all of these questions came from, is the Linux kernel was not written to be unit tested. It is not structured in such a way to be unit tested. So it actually turns out the code in the Linux kernel is actually pretty good in terms from, I would say in the grand scheme of things, all the different code I've seen. For C, the Linux kernel is like actually practices some pretty good modern software design patterns that help testing. There's a lot of good encapsulation, a lot of good code sharing, and there's even a lot of like object-oriented design in like driver stacks and stuff. So that's all great, and it's actually helped me a lot. If it already wasn't doing that, KUnit might not work, but it does. So the biggest issue that I've seen, which kind of, like, I think one of sort of the subtext here is that the whole running a kernel to run all of your tests inside the kernel is like a little kludgy. Like, I wish I didn't have to do that. But the problem is that dependencies in the kernel are poorly defined. There's a bunch of things that kbuild assumes you're always building a kernel. And so there's some things that every single kernel has to have. Like a kernel has to have a scheduler, right? Like how do you have a Linux kernel? Like how do you have an operating system kernel without a scheduler? Or like it has things like memory management and stuff. And those things are always included. It just assumes you always want something like that. And so you can't tease those things out to test them in isolation without having other code in the kernel as well. So if we could change that, that would be a huge, huge step forward in making the Linux kernel a lot more testable, in my opinion. So Does that make sense? Does everyone understand where I'm coming from with that point? Does anyone disagree? Okay. No, I think everyone, like, I don't want to say anything bad about kbuild, especially since like this talk's being recorded and stuff. But like, and I really like, I've used a number of build systems, and honestly, kbuild is actually one of the better ones I've used. But it doesn't do that. It doesn't act. It describes dependencies in terms of features, depending on other features. It doesn't describe dependencies in terms of this code depends on this other code to work. So I've not found anyone anyone I've brought that point up to is like, yeah, it would be really cool if it did that. I mean, I don't know that I've gotten people who are like really adamant about it, except for maybe one person, but yeah. So KUnit fitting into the test paradigm, I think it's I've tried to make the case that the Linux kernel doesn't really have unit testing outside of KUnit. I mean, you'd say technically it does have it now because the Linux kernel, the KUnit's been merged. But most of the test suites that exist, and there's a lot of them, I would describe most of them as end-to-end tests because pretty much all the test suites I've seen require you to boot a kernel somewhere, and you actually have to have like a user land and stuff. So there are some things that I would describe that are more unit testy, but most of them are pretty ad hoc. So as I was kind of getting at in one of the earlier slides where I talked about unit testing, I think that one of the rules of thumb I've seen in terms of like what kinds of tests you should have and how many of each tests, the way you get really high code coverage with unit testing is the fact that you're able to test so much code in isolation, so you don't have to deal with all the different possible states that your program can be in. But that does require that you need to have a lot of unit tests. So like 80% of your testing should, by a number of respectable people who I learned from, should say that 80% of your testing should be unit tests. And you should definitely have some end-to-end tests, but it should only account for about 5% of all your tests. And then the remaining difference should be made up by integration tests. So I think that KUnit covers the unit test case pretty well. We've totally got the end-to-end thing covered. Well, I don't want to say totally. Like, there's probably room for more end-to-end tests. There are some things in the kernel that are totally untested. But there's a number of test suites. Some of them do their job very, very well. I don't think there's really been any thought on the integration testing area. I've thought about it a little bit with maybe trying to bridge the gap between KUnit and kselftest, but that's kind of a tangent. I'm currently working on, as I already mentioned, Alan added support for making KUnit available as a module. Other things we're currently working on is improving UML, since we kind of use UML for running the majority of our tests. At least that's the intention. Yes?
Yeah, sorry. On the previous slide about the integration tests,
Yeah.
there are some things that have like torture tests and things like that. Would you consider those to be integration tests or like really big unit tests?
That's a good question. I'd kind of categorize torture tests separately entirely. But yeah, I think there's like one of the things, there's a lot, I've seen a lot of tests in the kernel where you can like inject failures and see how things happen. I would say in some cases that's sort of its own thing. In other cases you could probably think of it as kind of like end-to-end testing that's trying to get access to like some error paths that aren't usually handled. So I don't know, these aren't very clear-cut distinctions. Like by the very nature of integration being sort of in between unit tests and end-to-end tests, it's kind of hard. It's just, I think generally you can apply these labels to most of your things. So I know I pretty much just walked around giving you an actual answer, but
It's in the middle somewhere.
yeah. So
Slightly different question.
Yeah.
How do you, say, force races to happen? Like, is there utilities, helpers, and stuff for that sort of thing?
Forcing races to happen. Yeah, so I would say that's a very case-by-case sort of thing. That's not typically what you would do in a unit test. That's probably more of an integration test. But obviously, there's some things that, like, if you're writing, like, if the core of your algorithm is like a multi-threaded algorithm, like, in order to test that algorithm, you do need to do that. That would probably be a unit test, but no, I don't have any helpers to make it easier to do that. If you have any ideas on that, that would be maybe a good topic for discussion.
On the note of that,
Yeah.
if you want a primitive for doing that, the primitive you want is a cyclic barrier.
Is a what?
A cyclic barrier?
A cyclic barrier? Yeah.
So for those that don't know, a cyclic barrier is a primitive that blocks until you reach a certain number of hit semaphores and then releases them all at once. So essentially, it's you set things up in a particular way and then let them all go at once. So if you're trying to set a race condition up,
yeah,
set it up so it hits in the order you expect it to.
Yeah.
And then get it out.
So that gave me an idea. But one thing with the cyclic barrier, isn't that kind of like the completion API that the Linux kernel has?
I'm not a Linux kernel dev.
Okay.
These are much higher order constructs.
Okay. Yes. Yeah. Okay. Cool. Yes. So that you can just use the completion then for that. But the other thing that made me think of is, in some instances, a lot of the times where you may want to try to set up a race condition, like, obviously, if it's a core part of the algorithm, you might still need to try to actually do that. But if it is a race condition in terms of some sort of state dependency on a data structure, one of the things you can do is you can, in a test case, force the data structure into a certain state and then not do the next step, and then just forcibly do the thing that you're trying to protect against. And then your data structure should be safe against that. So that's the way you would typically do that in unit testing, but I know that doesn't work in all cases. So anyway, the last thing that we're working on is we're currently working on, currently working on getting KUnit to run as part of the kernel CI test suite. So things that we're planning on doing in the future, though, improving documentation. I guess probably something I should have mentioned in my talk is that I think one of the differences between, I was actually talking with Matthew about this at the beginning of the talk, or before the talk started actually, and we were talking about the role of test engineers, and I don't want to say that test engineers should always be the ones writing end-to-end tests, but I think for the vast majority of unit tests, they should actually be written by the developers who are writing the code. And the reason for that is one of the functions that unit tests serve is to document your code and to prove to the people who are reviewing your code that your code does what you say it does. So in order for that to be possible, we need to have really, really good documentation, because basically everyone needs to be able to write the tests. One of the next things we're hopefully going to work on soon is mocking and faking and creating like managed resources and stuff. So basically it will be really easy for you to set up sort of a fake environment. Like if you have a piece of code that depends on some piece of hardware, then you could mock out the underlying like lowest level driver layer, or maybe even make a fake implementation of that hardware inside the test. So there's a lot of discussion to go on there, but anyway, mocking and faking and the managed resources is one of the other things that we're hoping to be working on soon. Another thing would be solidifying the tap specification, which we use to communicate test results. That's kind of specific. And anyway, so that's actually everything I have prepared. No, we've already been talking, but I'm kind of interested in what some people think. We talked about the dependency problem a little bit, but if anyone has any ideas on that, I would like to hear what people think. Yeah, so I don't know. What do people want to talk about? Does anyone have something that they think would be interesting? Yep.
Yeah, I have a question regarding UML.
Yeah.
One of the problems with UML is that it runs the whole kernel. I mean, you need a dummy file system, you need console, and it also spawns threads or processes to emulate like init and other system processes.
Sure.
And it's not handy to debug simple systems. It's definitely good for, say, exit form, but not for simple system or simple models. So why people didn't consider to use the Linux kernel library instead of UML? Maybe that would be more appropriate for unit testing.
Yes, I've actually thought about that, and I think that's a great idea. The only reason that I use UML right now instead of LKL is because LKL is not currently merged upstream. I saw that there was some discussion on the UML threads, but I think the last patch that or the last RFC I saw was, I think back in October or something like that, maybe November. I would definitely, I've looked at it and there's some interesting things there, but obviously we can't use it until it's upstream.
So the problem only in that it's still not upstream and nobody wants to make an effort to put it to upstream, right? Because the people did effort to work with architecture and be compatible with UML. So only it seems that only small effort is required to go to the upstream. The guys send patches to LKML and at some point just the work stuck. So it seems they are not so far from being upstream.
Yeah. So yeah, it looked like, I mean, I didn't look at like every patch, but I looked at some of the patches and some of them looked reasonably good-ish. Like, you know, total disclaimer, I'm not a UML maintainer, so I don't speak for them. But I actually saw one of the UML maintainers actually said some pretty positive things about the patch set. So I got the impression that there were things that needed to change, but that like it was a positive conversation. It sounded like it just needed some work, and that it wasn't even a huge amount of work. Sorry, just for my own personal edification, if we maybe talk afterwards, do you work on LKL or?
Yes, we have considered to use UML in our code, in our project, and we end up with different. We implemented our own Linux kernel mocking, and we have our own unit test framework and functional test. So we do see we do look into UML and KUnit and the Linux kernel library.
Cool. I would love to talk to you afterwards then.
Okay,
so yeah, yeah, definitely. I will hit you up afterwards. So is there any other topics that people like to talk about?
One last question. Sorry, I'll go to this guy there because he hasn't had one yet.
Unit tests have to be maintained. Have you had any pushback from anyone about the maintenance burden?
Nope. Yep. I think that was quick. Does any other question? Maybe one more.
Do you have any example of sort of people who have adopted this in the kernel currently? Like what sort of people have been the early adopters?
Yeah. So I mentioned AppArmor wrote a test. I helped them a little bit, but they wrote the actual test. I just helped them on some of the issues because they were doing like a little bit of weird things. But they used it. There was, I'm trying to remember what the other. There was 2 other ones that I saw that I had no involvement with at all. So there were some people who sent tests upstream who I didn't help at all. Yeah, so let's see. I forget what they were called, but there's a couple examples. So I don't know, I guess maybe I can try to come up with a list of all the tests. Actually, so one of the naming convention we used for KUnit, so if you're curious, if you just download Linux Next, if you just search the menu config for KUnit, all the KUnit tests are have KUnit somewhere in the name. And so you can just see some examples there. Yeah, okay, yep.
So on a similar topic, I maintain 2, maybe 3 existing test suites in kernel, and it's using my own infrastructure to run them in userspace. They're built as kernel modules currently, like test_foo in lib. Is it worth converting them over to the KUnit framework at this point, or should I wait 6 months?
That's a good question. I don't know because I've not seen your tests. I've looked at some, I've talked with some people about converting some test suites over where it seems very straightforward. And we're currently doing that. I've also seen some other test suites where it wouldn't be ready for. So I think probably the best thing you could do, somebody just needs to look at it. And if you want to send them to me, I can give you a quick, what my thoughts are. So, yeah.
If you don't mind, we can carry on a bit later on this one because it is just Smoko after this. Any more questions?
I suppose just very quickly, since I think we do seem to have quite an audience of people who don't do a lot of unit testing.
Yeah.
Unit tests don't document what you did, they document what you meant to do.
Yes.
That's
a good point.
Difference.
That's true. That's a good point.
It's a really important difference. The unit test documents the intent of the implementer, not what they did.
That is true. Although hopefully your tests are good and they pass and they also test everything appropriately, and then they would hypothetically. But yeah, that's a good point.
Whoa, we've still got room, we've got room. Here we go.
Well,
I saved my extremely newbie question for the last and make everybody wait. Please address how this would work with the future wave of doing things with Kubernetes and containers. Maybe that's 0.
I would, yeah, so I would say that Kubernetes is kind of above the layer of what we're concerned with. I don't know.
That's for a polished production product, and this is for that. Development.
Yeah. Oh, are you asking how to do unit testing for Kubernetes, or are you saying?
Oh, so I work in an environment where I'm given a production environment, and I'm expecting, can you do a KUnit on that? Some kind of question.
Okay.
Looking towards the future of the unknown tasks that I will be given.
Mate, you have to talk into the microphone if you.
Yeah. Okay. Let's talk. But yeah, I think that unit testing is probably applicable. I mean, it should be applicable to any software project. So, actually, kind of one of my hopes is that bringing unit testing into a very visible place in the embedded space will hopefully create more awareness in other projects as well. So, I would hope so. Yes.
Right, now you guys can clap. That was a great talk.
Oh, thank you.
Thank you very much.
Thank you.
A little memento from LCA for you.
Oh,
You'll find it useful for your notes.
I appreciate it. Thank you.
Thank you very much.
Yeah.
Okay.
Thank you.